Hi, good morning. Today we are going to continue the topic finding area enclosed by two curves. So take a look at question number 1. We had two functions, y equal to 2x cubed minus x squared minus 5x, and y equal to negative x squared plus 3x. So we had this cubic function, and we have the parabola. So it enclosed two parts, part A and part B, or you can say R1 and R2. The question asks you to find the area of the shaded region. Use calculator. So now, because these two curves enclose two parts, I am going to call this R1 and this is R2. So if you look at R1 over here, so imagine that you are going to draw a rectangle. So you will find out that it is bounded by the top function, which is the y equal 2x cubed minus x squared minus 5x. And then the bottom function is going to be y equal to negative x squared plus 3x. As soon as it passes the 0, then the two functions swapped. So over here, we will find out that the height is bounded above by y equal to negative x squared plus 3x, and below by the y equal to 2x cubed minus x squared minus 5x. So the top function and bottom function swap after it passed the 0, 0. So right now, if you want to find the area of the R1, it's going to be integral from negative 2, the x value, negative 2, to 0, and then top function minus bottom function. And over here is from 0 to this point. Okay, now here, we don't know the x value. So we have to find the point of intersection. So we are going to use calculator. Okay, so now I am going to make my y1 equal to 2x cubed minus x squared minus 5x. And then I'm going to make my y2 equal to negative x squared plus 3x. And I'm going to change my window into standard window. Negative 10 to 10, the scale is 1, and then negative 10 to 10. And then we're going to graph. Then you see the same image. So we all know this point. We know this point, and we're missing this point over here that's not given in the graph. So we're going to do second trace, number 5, intersection. So now I'm going to move it to the point that I want to find intersection. Okay, so this is the closest we can get. So we put first curve, yes, second curve, yes, and guess. And then we found out the intersection is 2, 2. Now, we are going to use two integral. So area of shaded region equal to R1 plus R2. So for R1, we are going to use the integral from negative 2 to 0. And the top function is this one. So we're going to put 2x cubed minus x squared minus 5x. And the holding subtract. Your bottom function is a binomial, so you have to enclose it inside the parenthesis. And then dx. Now we are going to the R2. R2 from 0 to 2. So now my top function is going to be the parabola. So I'm going to have the negative x squared plus 3x minus the bottom function is going to be the 2x cubed minus x squared minus 5x, and then dx. So we swap the top function after the 0. Now I'm going to use my calculator because I already used my y1 equal to this one. And my y2 equal to the parabola. So when I enter in the calculator, I had to do integral -2 to 0, y1 minus y2 dx. And then plus, because over here we swap. So going to 0 to 2, y2 go first. So y2 minus y1, and then dx. And then we're going to type it into our calculator. So we're going to have math 9. The first one is -2 to 0. I'm going to do y1 minus y2 and dx. And then plus math 9, we have 0 to 2. And then you're going to do y2 minus y1, then dx. And then press enter. So we get 16. So therefore, we say that the area equal to 16. So the area for R1 and R2 added together is 16 square unit. So we finished question number 1. So let's take a look at question number 2. Question number 2. The question said no calculator. Let R be the region enclosed by y equal to x squared and y equal 4. Find the area R. So we had the parabola y equal to x squared, and we had the horizontal line y equal 4. So this is the area of R. So at this moment, probably you already noticed something. We do not have the point of intersection. So what should be the x value? We don't know. Then what should we do? We have the equation y equal to x squared, and we had y equal 4. We are not allowed to use calculator, but we still can find the point intersection. We're going to use what we learned in Algebra 1. In order to find the intersections, we are going to make the two equations equal to each other. So we get y equal to x squared and y equal to 4. So I'm going to make them equal to each other. So x squared equal to 4. And now we solve it. So x equal to plus minus square root of 4. So x equal to plus minus 2. So that means the point intersection is going to be 2, 4 and -2, 4. So the x value over here is 2, and this x value is -2. So now you probably noticed something. The parabola y equal to x squared is an even function. So let's refresh our memory before. The even function, okay, are going to be symmetrical over the y-axis. And the odd function is symmetrical over the origin. So this is an even function. And you have a horizontal line y equal 4. So that means this part over here is symmetrical to the other part on the second quadrant. So if this is the case, we're going to use the property that we learned before. If I find the area of this part in the quadrant 1 and I double it, then I will get the entire area. So this is using the property of even function. So now we are going to say that the area of R equal to integral -2 to 2. And then if you draw a rectangle, you draw anywhere in the region. The top function is going to be y equal 4, and the bottom is going to be the y equal x squared. So we're going to do top minus bottom, so it will be 4 minus x squared dx. And because this is going to be symmetrical over the y-axis, because the y equal to x squared is even, and this is a horizontal line. So we say that it equal to 2 times integral 0 to 2. And then 4 minus x squared dx. So somebody will ask, how come you didn't use -2 to 0? I want to deal with positive number, so I would do 0 to 2 instead of -2 to 0. You will get the same answer. So now once we get this, we're going to integrate. So 2 stay the same. And then I am going to have 4x minus x cubed over 3. And then I'm going to continue to find the number, and then times 2 at the end. So because I already used bracket, and I'm going to use braces, and then you're going to have bracket minus bracket. So over here we got 4 times 2 minus 2 to the third power over 3 and minus 0. And then you get 2 times. This is going to give you a minus a over 3. Then I'm going to continue. So I want to have the common denominator, so it'll be 3, and then numerator 24 minus a over 3. And then I'm going to subtract. So I get 2 times. This is going to be 16 over 3. And then you're going to multiply. 2 times 16 is 32. So I get 32 over 3. So therefore the area R equal to 32 over 3 square unit. So we finished question number 2.